So in this video we will learn about organic chemistry unit 10 haloalkanes and haloarenes. First of all, we will learn about what are the definition of haloalkanes and haloarenes. So the word itself indicates that haloalkanes means the substitution of halogen group into the alkanes. Such compounds are called as haloalkanes. Similarly, haloarenes means the substitution of halogen to the aromatic rings or aromatic substitution or aromatic compounds. So first of all, we will know about what is the definition of haloalkanes. Haloalkanes are nothing but the replacement of hydrogen atom or more than one hydrogen atoms in an aliphatic hydrocarbon. Aliphatic hydrocarbon is the one, it may consist of chain or branch, but it do not have any cyclic system. Such compounds are called as aliphatic hydrocarbon. So in that aliphatic hydrocarbon, by halogen atom means hydrogen atoms must be replaced by the halogen atoms. It will result in the formation of a compound or called as alkyl halides or haloalkanes. So just you can observable here example. So this is called as an alkane. So this is one of the aliphatic system. This is about the structure of alkane, that is one methane. So carbon has the property of tetravalency, so it should have a 4 valency. Each valency must be satisfied by the each hydrogen atoms. So how it would get converted into haloalkane means methane get converted into haloalkane. So how it will be, any one hydrogen, this hydrogen or this hydrogen and any one hydrogen must be substituted by the halogen atoms. It may have one halogen atoms or two or more than one halogen atoms. Now CH4, it is called as a methane. Now the molecular formula for methane, it will get converted into CH3, means methane get converted into methyl, because alkane, this is called as alkyl. When we will call it as an alkyl means whenever the product must consist of one hydrogen atom lesser than the parent one, so it is called as an alkyl group, so it is called as methyl. So halogen group it is substituted, hence it is called as a methyl halide or alkyl halide or haloalkane. Similarly, haloarenes, the difference between haloalkanes to the haloarenes, here hydrogen atoms in an aliphatic hydrocarbon, here hydrogen atoms in an aromatic hydrocarbon. That is only difference. Aromatic in the sense it should have a cyclic system. Such compounds are called as haloarenes. Now you can observe that this is in one of the arene or benzene. Each carbon atom has hydrogen atoms. So any one hydrogen atom must be replaced by the halogen atoms. So it will lead to formation of aryl halides or haloarene. So these are the definition of haloalkanes and haloarenes. Now you can have an idea about what are the applications of haloalkanes and haloarenes. There is involvement of wide range of applications in industry as well as day-to-day life. And secondly, you can observe that it is also used as a solvents for relatively non-polar compounds, and mainly it is used in organic synthesis of like synthesis of organic compounds. And very important two applications we can observe that chloroquine and halothane. Chloroquine it is used for a treatment of malaria. Halothane is used as an anesthetic during surgery. So these are some applications. Among those, you should remember these two are very important applications. In this unit or concept, we will study the classification of haloalkanes and haloarenes. What are the classification of haloalkanes and haloarenes? Okay, here they have included as some follows. There is involvement of some sub-classification. Among those, we can understandable some classification here. See, first of classification on the basis of number of halogen atoms. Means how many number of halogen atoms are substituted, on the basis of that it is classified into mono, di or polyhalogen compounds depending on whether they contain 1, 2 or more halogen atoms in their structure. So here C2H5X means the parent one, it will be C2H6. It must be one hydrogen atoms replaced by the one halogen. So the whole compound, it is consist of only one halogen, so it is called as a monohaloalkane. Similarly, this whole compound, it is consisted in the case of 1 or 2 halogen groups, so this is called as dihaloalkanes. And here there is involvement of 1 or 3 halogen groups, so this is called as trihaloalkanes. And similarly, arenes also, this it will consist of the only one halogen, so monohaloarenes, 2 halogens dihaloarenes, 3 halogens trihaloarenes. Like this, among those alkanes and as well as arenes, monohalo compounds may further be classified. Means these two compounds further classified according to the hybridization of the carbon atom to which hydrogen atom is bonded, as discussed below. Means on the basis of hybridization, monohalo compounds are classified into two types. One, it is sp3-CX bond, means sp3 hybridization wise, and another one it is sp2. First one we should know about sp3-CX bond. So in that first one, alkyl halides or haloalkanes. So alkyl halides, it is nothing but one halogen atom is bonded to an alkyl group. Such groups are called as an alkyl halides. So there is having one molecular formula CnH2n plus 1 2x. They are further classified into primary, secondary or tertiary according to the nature of carbon to which halogen atom is get attached. For example, primary alkyl halide. What is the meaning of primary alkyl halide? Here, if halogen atom is attached to a primary carbon atom, means the halogen consisting of a carbon, now it is called as a primary carbon atom. So such type of an alkyl halide are called as primary alkyl halide. Similarly, you can understandable here, this is called as a secondary alkyl halide. Means if halogen atom consists in the case of attached to the secondary carbon atom 1, 2, this is called as secondary carbon atom, so it is called as secondary alkyl halide. Similarly, tertiary in the sense, instead of 2, the carbon consists of 3 alkyl groups, so such type of an alkyl halide is called as tertiary. This is about the primary, secondary and tertiary. Next one, that is first one alkylic, second one is allylic halide. Allylic halides, it is nothing but one, these are the compounds which the halogen atom is bonded to an sp3 hybridized. These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom adjacent to the carbon-carbon double bond, that is to an allylic carbon. So for example, you can observe that here the halogen atom is not directly bonded to the double bond, it is bonded through the CH2 group. So such carbon is called as allylic. Similarly, here also halogen atom, it is not directly bonded to this carbon atom, it is bonded through the CH2. So such carbon atom is called as allylic. So third one, benzylic halides. So benzylic halides, it is also similar way. Allylic to the benzylic, the difference will be here it is an aliphatic system, here it is called as an aromatic system. Means benzene ring must be present. So such type of halides are called as benzylic halides. Then third classification, that is sp2 hybridization, like sp2-CX bond. In this class includes vinylic and aryl halides. So vinylic halides, it is nothing but opposite to the allylic. Means the halogen atom, it is directly bonded to the sp2 hybridized state of carbon atom. Means it is directly bonded to the double bond of a carbon atom. Such halides are called as vinylic halides. Then aryl halides, it is nothing but the halogen atom, it is directly bonded to the sp2 hybridized state of cyclic system, means it is opposite to the benzylic and it is opposite to the allylic. So this is about the classification of haloalkanes and haloarenes. So if you have any doubts, please comment, and if you like my video, please subscribe.